This is going to be your notes for lesson 40, and I'm going to try to do this in 2 parts so it's not too long. It is a long example. If you have a chance to take the soft copy of the notes and print out a copy, it might be better for you, and then just go ahead and include it in your notebook. Otherwise, whatever I write on my screen, you can also take the time to pause and write down the questions as they come up. Most importantly, you should sketch this graph here. It is a cubic polynomial. What else do we see about this? Let's zoom in a little bit. It's a cubic polynomial. It has an x-intercept at x is equal to 1. It has a relative maximum here, and it has a relative maximum here, minimum here, and it's some kind of cubic function. So just like before we even start, I just wanted you to scan this graph to see what we're dealing with. Otherwise, you can title your notes Lesson 40, and we're going to talk about removing some obstacles. And today's lesson is great because we have spent all year working on lots of different skills, and we're going to use almost all of our skills in these 2 videos. So hang tight, get excited, look at the vocabulary. It's words that we've seen all year: real solution, function, cubic polynomial, end behavior. Remember end behavior? Infinity. We're going to talk about solutions, different types of solutions, remainder theorem. Remember remainder theorem? Factor, imaginary, linear factors. So we have a lot of words going on here, and we're going to put them all together in the next couple videos. So if you don't have the notes printed out, the most important thing you can write down is this function here. P of x is equal to this cubic function, and then also sketch this graph. And as the video goes on, the graph should just reappear every time we move the screen. So you will not be missing the graph at all. But let's read this. So it's only one example, but there are many parts. Considering this polynomial, whose graph is shown on the right, looking at the graph, how do we know there's only one real solution? And so if you're writing this on your own, in your own notebook paper, you should be boxing real solution, or you should be highlighting real solution. And in the previous videos, we said that real solutions happen at x-intercepts. So we know there's one real solution here. Let's zoom in. At x is equal to 1. So that's our real solution. I wonder if I should type. There is a real solution at x is equal to 1 because that is where there are x is an x-intercept. Okay. All right. So B, is it possible? I'm down here. Is it possible for a cubic polynomial function to have no zeros? And this is where we have this conversation again about a cubic polynomial has a range, all the y values. So we're bringing in our prior knowledge. It has a range from negative infinity to positive infinity. There must be a point where y equals to 0. In a cubic function, there's got to be a point where y is equal to 0, because if our range is from negative infinity all the way to positive infinity, somewhere between negative infinity and positive infinity is 0. And so that is why in our cubic polynomial, our range goes from negative to positive infinity, and it has to cross the x-axis at least once. And now you can think to yourself, and you can ask your teacher this, or me this, what is the most amount of times a cubic polynomial can hit the x-axis? All right, write that down when you annotate. Okay, let's move on to part C. Part C, from the graph, what appears to be one solution of the equation? Now, we know solutions happen, so let's annotate this. The solution of an equation, this happens when y is equal to 0. A real solution will happen when y is equal to 0, because that's where the x-intercept is. So we already said x is equal to 1 is a solution. Okay, so if we have solution, what is the factor? We did this in a previous video. So if x is equal to 1 is a real solution, then the factor is going to be x minus 1. Woo! How can we verify that this is a solution? Well, we said when y is equal to 0. The other thing that you have to remember is that p of x, whenever we talk about a function and we say p of x or f of x, that is also equal to y in this case. It means whatever we put in for x, we're going to get a y value. In this case, the y value is 0. So let's set 0 equal for y, and y is also equal to our function, our polynomial function. All right, so they actually gave us this equation already. Let's evaluate this equation at 1 to see if it is indeed equal to 0. So it is a solution. I'll write that. X is equal to 1 is a solution if we plug in x is equal to 1 into the function and we get 0. Okay, so let's try it out. Let's plug in x is equal to 1 into this function. All right, so 1, 1, 1. 1 cubed plus 3 times 1 plus 1 minus 5. Let's see if this is equal to 0. And we do our math really quick. 0 is 0 equal to 1 plus 3 plus 1 minus 5. Is it equal to 4? Oh my gosh, is that a 5? I meant 1. 1, 4 plus 1 minus 5. Is that equal to, I'm going to combine these two. 5 minus 5. Is all this equal to 0? Indeed, it is equal to 0. Thus, because we plugged in x is equal to 1 into the polynomial function and we got 0, that means that x is equal to 1 is a solution. Very much is a solution. X equals 1 is a solution. Okay. Part E. According to the remainder theorem, what is one factor of the cubic expression? So let's remind ourselves what the remainder theorem is. Okay. So the remainder theorem. That is when if you have a polynomial function p of x, and then if you plug in, and then if you have p of a, and if it is equal to 0, so say you have a polynomial function, and then you plug in an a value, whatever number they give you, like we gave you 1 before. If that makes the equation equal to 0 with no remainder, then, or it has no remainder, then x minus a is a factor of p of x. So what we're doing is we are testing our solution to see if there is a remainder in our polynomial function. If it's equal to 0, that means there's no remainder, and that means that x minus a is a factor of p of x. All right, so according to the remainder theorem, what is one factor of the cubic expression? So we have a real solution, we mentioned this earlier, versus a factor. We confirmed that the real solution was x is equal to negative, x is equal to positive 1. Therefore, our factor is x minus 1. Whew! Good. Now, let's rewrite our polynomial equation. We started with p of x is equal to x cubed plus 3x squared plus 5x minus 5. Now, we're going to have x minus 1 and some things left over. How would we find out what's left over? Well, we're going to factor x minus 1 from the original expression. So I'm going to do long division in this example, and then in my next video, I'll do box method. So if you prefer box method, then start setting up your box now. But if you're doing long division, you can work with me. X cubed plus 3x squared plus x, minus 5. All right. Long division, we need to find what times x will give us x cubed. Oh, that's a 1. Oh, this is a 3. 3 minus negative x is 4x squared. Notice my parentheses here. X, oh my goodness. Oh my goodness, I'm so sorry. I just keep messing up on my long division. X minus negative 4x is going to be positive x. Wow. Wow. Okay. Nope, I don't want to highlight that. Calculation error. All right. Wow. Whew. No remainder. Okay, what does that mean? So we factored out x minus 1 from the polynomial. That means our polynomial we can rewrite as x minus 1, and now we can write it as x squared plus 4x plus 5. My question for you is, do you think we can factor that x squared plus 4x plus 5 even more? So next video, let's talk about that in the next video, and then I'm going to pick up with box method for this problem, okay? Next video.